Hey guys, welcome back. So in this video we'll define a task for a bit more interesting task than we saw before. Previously we did this word count example. From now we will be writing pipelines that will process the tweets and will evolve our pipeline and the requirements as we go along. But for now I've decided to somewhat similar to word count, but but it's a bit more involved. Like for example, we'll be reading the files and then parsing the JSON in there and then mapping them to our Java plain Java classes, then using that, and then we'll only extract the users who have posted like at least some amount of tweets in the given time period. So although it's quite similar to word count, we are also counting the number of posts made by a user. But here we'll demonstrate like how to read the JSON file, then some of the shortcuts, we use these map elements, and then we had to pass a simple function, blah blah blah. But we'll look around some of the different ways that we can do the same things, and we'll again like evolve our pipeline and then continue further in the future videos. So for this I've added a couple of not couple of dependencies, but only couple of dependencies. So here I've added this Java extension called JSON Jackson. So Jackson is a library in Java that we can use to parse JSON data, and Beam has already this extension, so we'll be using this one. And I'm also going to use this Lombok library. If you already know, then good about this. Otherwise it's just a simple library that provides some annotations. Here for example in this Java class called tweet, so I've defined a class that implements serializable. I'll show why we implement the serializable. And this annotation that you see, this add data, comes from Lombok library. What it makes is like creates a getter and setter, so we don't have to define it ourselves. So it's like kind of shortcut, and it has a lot of other annotations to help you make this builder classes and everything. So it's quite it makes your classes quite short and eliminate the verbose getter setter stuff. So before I show you the rest of the stuff, I've used this library called Twark, and basically you install, go to Twitter, get your this access token and all. Then once you have that, you can just use this Twark command from command line, and that is how I have the data, these Google Tweets and Google Tweet Small, just for demo. So I just ran this command Twark search Google, and I just saved it to this Google Tweets file. So this one is about 50 megabytes. I don't know how many file we have. Okay, only preview of 2.4. okay, so it's basically like every line in the files, either this one, like it has 10, only 10. Every line is this JSON data, and that directly comes from the Twitter. So we have a lot of fields created at blah blah blah, information about the user, hashtags, everything. So right now we don't care about all those data, so we only are interested in the full text, that is the actual tweet, the language of the tweet, the user who posted the tweet. And because the JSON properties are in this I think this is called snake case here, we tell the json library using this annotation that okay, if you see this full text, full underscore text, then map it to the property called full text. And if they are same, like lang, in tweet, the tweet also there are just the lang properties, so these directly map to this, so we don't have to annotate anything. And similarly here, ID, name are same, but screen name here in Java we have this in camel case and this one in snake case. So I've just included this one. And this ignore properties, there are a lot of other properties besides these three, and also in the user. Let me show you the formatted tweet. So this is a single tweet, and there are a lot of information that we don't exactly need and we don't care about them right now. So that's why we have this ignore properties to true. And basically this is all. So implement serializable, again we'll go back to we'll come back at this later. And I have this tweet pipeline. I've just defined the same thing as before. In the word count example, we create empty options, create the pipeline using that option, then we run and wait until finish. So the goal in this video would be to read the tweets, parse the JSON, then extract the usernames and discard the usernames having tweet count less than 6. So we'll count how many times each user tweeted, and then we'll discard all of the usernames that don't have at least 6 tweets, and then we'll write the names to database, or for now let's just do it on file. So again, similar like we did before, we will first apply text IO transform in the pipeline .read .from. For now I'll just use Google small.jsonl. This will be lines. Then right now it's a p collection of string, so each line is can be parsed as a JSON. So because we have added this Jackson extension of Beam, we can use that one to parse the parse and create our tweet data, this tweet object. So now we can do lines.apply. Then there's this function called parse JSONs.off. Then we need to tell it what kind of class it is, tweet.class. And if we look at the p collection, now we have a p collection of tweet objects. So tweets. Now that we have tweets, if we look at the attributes of this class, we have this field called user, and user has other stuff as well, ID, name, screen name. Right now we'll extract the screen names. So screen name is again a string, so we want a collection of string. Now what we can do is tweets.apply, then map elements. Then if you watch the previous video, we just used this sphere and then used a simple function and blah 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 to create our this map elements transform. But we'll use shortcut and use the lambda in Java. That it's quite it makes the code quite short and concise, so we'll use that one. So for that we need to specify this into, and we need to tell what kind of output are we going to produce. So map elements into, then there's this type descriptor. You can use either type descriptor of string.class, or because string and there are some other data structures, the classes that are frequently used, Beam already has this another one called type descriptors dot strings, iterables, and blah blah blah. So right now we're interested in strings, and now that this map elements will know that okay, whatever the lambda function is going to be there, it will produce this string output. So we'll also use the same this via function, but here instead of creating a new simple function anonymous class, we can just say okay, tweet t.getUser.get screen name. If we don't do this into thing, then it won't work. So if we want to use lambda, here we have to specify the type that we are returning here using the into function as well. So let's call them users. Now users, we want to discard the users who have posted tweets less than 6 times. So then we need to count those guys. So first what we do is, again similar to word count example, count per element. So it will assign this transform will create a key value, p collection of key value. String is our username, long is the number of times this username was seen in the p collection. So then we'll apply. Now that we have username and the count, or the number of tweets that this guy made, so we can use that to filter out or discard the some of the usernames. So there's filter, there is already a built-in transform called filter, and we'll be using this by function, and in predicate, because this is a key value, we can use this lambda function key value dot get value is the count, and let's say is greater than 5. So after applying this, the p collection that we have, this one will only contain the users who have at least 5, no, at least 6 tweets. So now we want to let's say frequent users for now. Now we want to write the usernames to file. So again, if we look at this word count pipeline, here we have the similar key value. Here we use this map elements, and we created this anonymous simple function, apply, override, blah blah blah. That is too long. So what we can do is frequent users dot apply, and then we can do map elements into, we want to produce from this key value, we want to produce a string because we want to write it to a file. So type descriptors dot strings will be producing that. Yeah, we'll just use object to string. This is again another Java shortcut. So this will produce from a p collection of key value, it will produce a p collection of string. Then we'll apply text io dot write dot to let's say tweet count. So once we've done that, it should run tweet small. So here we see that unable to return a default coder for parse JSON's map element blah 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 blah. Correct one of the following root causes. No coder has been manually specified. You may do so using .setCoder. So in Beam, because the pipelines run in a distributed fashion, like across multiple machines, they may be heterogeneous as well. It needs to let's say serialize the data in the P collection. So string and the built-in types like long, integer, they are already handled by the Apache Beam. So Beam, since it's all of these kind of data types are already in the Java SDK, Beam has provided this what is called as coders for most of these. But for example, here in our case, this tweet is like a custom. We made our own class, but Beam does not know how to serialize it. Serialize may not be the proper word, I'm not really sure, but it's so that however we decide to, let's say, serialize the data in the P collection. For example, where did that go? Yeah, tweets. This P collection, let's say we have billion tweets in this P collection and it's spread across like 50 machine or something. All of the machine need to have the same representation of tweet. So tweet object. So however it's represented in machine 1 should be represented in exactly the same way in machine 2 as well. So Beam uses this coders to handle all this serialization, deserialization, and because this is our own data type, and we need to specify how to serialize this. And this parse JSONs of tweet class, when we do this, it's complaining here. We see that it's complaining that there is no coder, and now we have to specify the coder ourselves. So what we can do is set coder, then serializable coder.off class. Note that now now that from this P collection of string we apply this parse JSON, and whatever the resulting P collection is, this tweet will have the coder, serializable coder, that will serialize the tweet class. That's why we have this serializable over here. The serializable coder will only work with the classes that implement serializable, this java.io.serializable interface. But there are different coders, other coders as well. For example, Abro coder, and you can use that as well. Abro coder is portable than serializable coder. For example, you can only use this serializable coder only for the if you are going to use Java. If whatever the data is serialized using Abro coder, it doesn't matter which programming language you use, you can deserialize back again using completely different programming language as well. So there are like different mediums or different ways how you can serialize. For this demonstration, since this serializable coder is most easiest, I'll be using this one. And you can use Abro coder if you have some binary data and you need to some external binary data and you need to process that, or you have some kind of schema and all. So it depends, but just remember that if you get something like this, something about coders, and if you definitely use your own classes, then you need to specify the coder. Right now I've just set the coder here when creating this P collection, but there is another way as well. We can configure the pipeline to register the serializable coder for tweet. whenever it sees a collection of tweet class, then it will automatically apply the serializable coder instead of us having to specify this set coder everywhere. So there's another way which we'll go through in the later videos, but for now just remember that you'll need to specify the coders, and it's pretty important to for Beam. Next thing is pretty simple, map elements. We use this type descriptors .string so that we could use the Java lambda function here. If we didn't, then we'd have to use this map elements via, then create an anonymous class, and then override this apply function, which is quite long, but this looks pretty short and neat. And then we use the new transform, filter transform, which is also a built-in transform, and then we again use this into function to define the type descriptor, and then use the Java lambda function to convert the key value into a string. Then we use the text IO to write to the file. Now let's run it again and it should work. So we have this file as output, and if we see, it's completely blank. I'm not sure why. Or maybe in the small one, there are only 10 tweets there. So let's run this for the whole dataset. The first one is blank. The second one we have 6, 7. So these guys with 6 tweets, 11 tweets, and again, like, we don't see any users who have less than 5 tweets. So this is what we expected. And so with this I'll wrap this video. In the next video we'll look at how we can extract the hashtags. So basically we'll be learning how to produce more. For one input we can produce multiple outputs as well. So we'll see that from one tweet we'll produce multiple hashtags as output. So we'll look into different things that we can do, and we'll look at another powerful transform called pardo, so which is quite flexible. So we'll look at that, and also look at the pipeline options and pipeline coder registry, which allows us to register the coders for custom objects that we use only once during the pipeline construction, and so we can totally ignore this kind of manually specifying the coders everywhere. So thanks for watching. See you in the next video.